This is question 14 on the 5.2 My Lab Math homework. So we're told the marginal price for a weekly demand of X bottles of shampoo in a drugstore is given by the function shown below. So the marginal price, P prime, is given by this function. And we're being asked to find the price demand equation. So we know that if we have marginal price, that's the derivative of the price, and we integrate that, it's going to give us the price back. Well, a generic form of it. There'll be a constant on there. So let's go ahead and do that. I'm just going to take that price demand equation, that rule, and make that my integrand. So that's negative 6,000 over my binomial squared. Okay, and I have to figure out which reverse rule we'll be using. And I see a fraction in here, built into my integrand. So it's really tempting to use the reverse ln of x rule, but we're not going to do that. To use the reverse ln of x rule, we have a fraction, but the denominator of that fraction, it needs to have an understood exponent of 1. And right now there's a binomial in the denominator of the fraction, and it has an exponent of 2. So we're not going to use the reverse ln of x rule. Instead, we're going to use the reverse power rule, because I'm just going to relocate that binomial from the denominator to the numerator using a negative exponent. So I had that negative 6,000. I relocate the binomial. Its exponent's now a negative 2. And it's getting closer to the reverse power rule setup. I can pull out that negative 6,000. It's a constant, so I can pull that out of my integrands. And I'm getting a little bit closer to being able to use that reverse power rule. But to use the reverse power rule, I need a plain variable as my base, and right now I have a binomial as my base. I have a constant exponent, so that part's okay. It's just that base, so I need to use some u substitution here. So I'm going to let my base, that binomial, be my u, and then I'll just do my steps for u substitution. So I'll go ahead and take the derivative of u with respect to x. That's just going to be 3. I'll relocate that dx to the other side. So du is equivalent to a 3 dx. Okay, well, what's going on here? I have the dx, I have that part, but I don't have a 3. Okay, so what I'm going to do is I'm going to divide off that 3. I'm going to get rid of it and leave just that dx that I already have right there. So I'll have to divide 3 on both sides. And then what that gives me is, there's an understood 1 there, and from that du, that 1/3 du cashes in for my dx. So where I see a dx, I can replace it with a 1/3 du. So when I go ahead and rewrite all of this, I have that negative 6,000 that I pulled out from the beginning. And then my base, that binomial, becomes a u. So I have u to the negative 2 power, and then that dx is going to swap out for a 1/3 du. And again, I don't need that 1/3. I can go ahead and pull that out of my integral. So it'll be side by side multiplying with that 6,000. So you can just type that in your calculator. When I multiply those out, that's going to give me negative 2,000. And then I'll have u to the negative 2 du in there. And now it's set up to follow my reverse power rule because my base is a plain variable. I have a constant exponent. So I'm just going to follow my reverse power rule there. Okay, so that'll give me, oh, don't forget that negative 2,000 we pulled out. So that'll give me u to the negative 2 plus 1 over negative 2 plus 1. And then I have a generic plus c as my constant. Okay, well, I'm not done. I need to clean that up a little bit. So, I've run out of room. So let's come over here. So that's going to give me a negative 2,000 u to the negative 1 exponent over negative 1 is my denominator plus c. And then I can clean that up a little bit more because I can do negative 2,000 divided by negative 1. That's just going to become a positive 2,000 u to the negative 1 plus c. And don't forget to unsubstitute that u. Remember, we did the u substitution here. We need to unsubstitute that. So, and remember, when we did all of this, we're getting our price demand function back. So I'm just going to say, okay, what is my price demand function? When I unsubstitute that u, it's 2,000 u, which was the binomial 3x plus 50, to the negative 1 power plus c. Now, that's my generic price demand function. They gave us some extra information we can use to find that constant. So let me clear up this screen and then we'll find that constant using the extra info. Okay, we were told that if the weekly demand is 150 bottles, oh, I hate that they didn't put the unit on that 150. Demand is number of bottles. When the price is $4. Okay, so what does that mean? That means if I plug in 150 bottles and I follow this rule to calculate my price better come out to be $4. So let's go ahead and do that and see what we get. So I'm just plugging 150 in for my input, for my demand. So that's going to be 3 times 150 plus 50 to the -1 plus C, and that has to equal $4. So I'm just going to enter all this into my calculator and get a number for that. Ooh, I got 4. So if 4 plus C equals 4, then C has to be 0, right? If I just subtract that off. So in this case, my constant is a 0. And that's just luck of the draw with the numbers I was given. On your version of your homework problem, your numbers might give you a different constant for C. But I got that my constant was 0. So actually, my specific function, for this specific information they gave us, looks like this. It'd be my price demand function is 2,000 times the binomial to the -1 power plus 0. So I don't really even need to write that. And now I can use this specific function to find prices and demands that are linked together for other conditions. So which one condition did they give me? Oh, the price was $5.50. So it's asking me what the demand is if the price is $5.50. So it's actually a little trickier because we're being asked to find an input that's going to create an output of $5.50. Okay, so let's think about that a little bit. Let me set up this function here. So the algebra might be a little bit trickier than we're used to, but that's okay. We got this. I'm trying to locate or figure out this x that's trapped in this binomial, that's trapped by this exponent that's being multiplied to -2,000. So the first thing I need to do is get rid of that 2,000. So let's just divide both sides by 2,000. And what that's going to do is it's going to at least get my binomial to the -1 power alone. So I'm typing this in my calculator, 2,000, and that gave me 0.00275. Okay, I still need to get to this x that's in this binomial that's being trapped by that exponent. So I'm just going to raise both sides of this equation to any exponent that I want. Oh, give me 1 second. I had that on white. White doesn't show up on white. So I could square both sides of this equation if I wanted to, but squaring doesn't really help me that much. So what I'm going to do instead is I'm going to raise both sides of the equation to the -1 power, because when I multiply those exponents, what's -1 times -1? +1. So that's going to give me my binomial to the +1 power. And we don't need to write that understood exponent of 1. So that frees my binomial. And then I'll type this into my calculator. So that decimal value to the -1 power, is going to be 363.636363, repeating. I'm going to write a couple decimal values out so I don't round too much. And now it's just a simple algebra function. I'm just going to subtract 50 on both sides, and then I'll divide by 3. So I'm subtracting 50. And again, I have a long decimal number. I'm just going to keep it running in my calculator, but I'll write a couple decimal places down here. So now, divide both sides by 3. And I get x is 104.5454, repeating. And we're being asked to find the number of bottles to the nearest whole number. So I would round that up to approximately 105 bottles. So if the price is set at $5.50, then I can expect to sell or supply 105 bottles at that price point.